For the second video, I'm using FLIR Thermal Studio to calibrate and analyze our infrared thermography images. I'm going to show you how to find emissivity. And for this one, again, I've navigated to my folder, and I'm going to show two different emissivities. One object that has a fairly high emissivity, a second object that has a much lower emissivity. So remember from the last video, we had our reflected temperature, and there, you can see if I hover over it, we got a reflected temperature of 78.1, and that'll be important as we do emissivity. So I'm going to open this image up. And typically when we use the camera, we often have the center spot enabled, and so you can see there's a center spot measurement here. This doesn't help us much or mean much, so I'm going to select it, and I'm going to hit delete to get rid of it. Now, you can see in the visible image on the right, this is a kind of a corrugated roll-up door, and I have my electrical tape roughly in the center that has a known emissivity of 0.95. And I'm going to try to find out, I want to know what the emissivity of this surface is. And so right now this is in MSX mode, just to show you. If I go into thermal mode, you can see it's fairly hard to see the tape. And that's because that's telling me right off the bat that the tape, an emissivity of 0.95, is probably fairly similar to the surface treatment, the paint that's on the door. And so in order to make it easier to find the tape, when we're putting our boxes here, I'm going to go into the MSX mode. Now I can adjust how much how much of a visible image, more visible image or less visible image. And I just need it just enough I can see the tape. That adjustment isn't going to affect any measurements, but it's just something that you can see. So now I'm going to start finding the emissivity. The first thing is reflected temp. We need to adjust this to match what we found the reflected temperature to be. In the last video, we found that it was 78.1 degrees Fahrenheit. So I'm going to put that in. I'm going to hit enter on my keyboard or return. And so it'll put that in there so that the software can compensate for that. My distance, I had my camera at roughly 3 feet, so I had actually set my camera for the proper distance. The room temperature was 68 degrees. We didn't use any external optics, so that's at 100 or 100%. Relative humidity in the environment was about 50%. And so I set that in the camera, but I could adjust those now if I needed to. And now I'm going to go ahead and use those measurement tools again in order to find the emissivity of the paint. So first I'm going to get my rectangle tool again. And the first rectangle I'm going to create, I'm going to put on top of the tape, and I want it to cover a lot of the tape, but not pick up any background. So you can see here I've made it the size. If I need to adjust it a little bit, you can grab things like corners or edges. And it doesn't have to be exact. I'm just getting it to cover the majority of the tape. And so you can see if I select it, it says box when it gives me max, min, average. At the end of the day, the only thing I'm worried about here is the average. So I'm gonna turn off enable hotspot. I'm gonna turn off enable cold spot. I'm gonna leave enable average. I'm also not worried about knowing where the hot spot and cold spot are, so I'm gonna shut those off on the display submenu. And then down here, local parameters for this one, we need to, just a quick, if I go out of that, you can see for the main image right now, the emissivity is set at 1. We know the emissivity of the tape is 0.95, and we're going to try to figure out what we need to change this to, which will be to compensate for the background. So I'm going to click back on my box. I'm going to click use local parameters, and I'm going to change that to my known emissivity of 0.95. The reflected temperature stays the same and the distance is the same. I'm just going to hit enter. And so now it tells me that my box, the temperature average for the box is 98.1. And if I can change the name, I can call that tape. I don't know. So there is our tape box. The other thing you'll notice is on the tape box right now, there's a little asterisk or a star after the name. And that is on there so that if I'm looking at the image, not with the, not the tape, not this tape parameter settings, but if I look at the image settings, it doesn't tell me anywhere what that the tape box has its own emissivity. So that star is telling me it's using local parameters rather than the global parameters that are adjusted over here on the right when the box is not selected. Now I'm going to create a second box, and I'm going to put it right here, kind of in a generally similar area, similar size as my tape box, and this is box 2. You can see it came up over here. And again, I'm not worried about hot spot or cold spot. I want average. I don't need hot spot or cold spot markers. And for parameters, I'm not going to use local parameters. I want to use global because I'm trying to adjust the rest of the image to calibrate the emissivity for that surface. So this box is going to use whatever I have the parameters set for the rest of the image. And this one I'm just going to call bare surface, which is the painted surface instead of tape. And you can see this one next to bare surface, there is no star next to it, which means it's using the global parameters. And if we look at these, the tape versus the bare surface, you can see the average across there is different. I'm gonna make the tape box just slightly bigger, but still you can see the average. It shows that the average on the tape here is 98.1. and the average on the bare surface is 96.7. Those two areas are roughly the same. Even if I drag this around a little bit, you can see, it doesn't change when maybe I get it up to 97 because there is a cold spot kind of in the middle here where it drops down to 96.7. If I go over here a little bit, it's still 96.9 or 97 roughly, but it doesn't change a lot. Now, if I put it on one of these spots where there's kind of a crack in the door, a thin spot, it's going to get hotter, but I want to make sure I'm on one of these panels. This door has panels, so I'm comparing a panel above to the panel where my tape is at. So again, by having a box like that, it gives me an average. I can even make the box bigger if I want to get a bigger average. You'll see it's still 96.9. So now what I have to do is I'm saying, the average temperature in any given area on this door should be about the same temperature, but my measurement boxes are saying it's not. And so I have to adjust. What's causing that is the emissivity is not adjusted correctly. So in order to get that, I'm going to start to just change the emissivity. So you can just watch what happens. The bare surface temperatures, I start to bring the emissivity down, and I'll bring it to 0.9. We'll go to 0.9 and I'm going to hit enter. And you'll see now the bare surface, it shows the average temperature there is 98.9. So we actually overshot it. So that means the bare surface, the emissivity is lower than 1, which the only thing that would be 1 would be a true black body or a totally non-infrared reflective surface. I went down to 0.9 or 90%. Emissive, and it's showing that the temperature is too high, so that tells me I went too far. I'm going to go ahead and I'll put a 3 next to that. So let's try 0.93. It gives me 98.3. It's still a little bit high, so maybe I'll put a 2. Oh, wrong direction. I'm sorry. Maybe I'll put a 4. And it brings it to 98.1 degrees. If I put in 0.95, it goes down to 97.9. So, but when I put in 0.94, you can see now my bare surface, which is using these image global parameters, matches my tape, which is a known 0.95. So that tells me that the emissivity of this material, the surface coating on this door, is 0.94. And I'm going to go ahead and save, and I can then exit, and that gives me my information in order to find emissivity. So what I would do then is I would take that 0.95 or 0.94, excuse me, and I could put that in all pictures of this surface. So anything that has the same surface coating, I would use that emissivity of 0.94 to know that I'm getting accurate temperatures and accurate differentials of my temperatures. I'm going to go ahead and stop here, and I'll create kind of a part B to this video, where I'm also going to do the emissivity of a stainless surface, which is much more thermally reflective.